So the next thing I have to do is initialize this thing. To get it started, I have to I have a bunch of rope strings that I need to put into a free list. And not sure if I'm using that term correctly, but what I've always meant by free list is like a list of things which are free that you can pop something off of. So I have my that list of free rope strings, and then December 12th. Interesting. That'll be the date when I have been working on 4coder for a year. I just got curious for a second there. Anyway, the rope string. The rope strings need to be initialized inside data, and I need them all to point from one to the next. Okay. And I need to space them out by 256 bytes each. So I should go work on that because I got that wrong. That is down here. When I figure out, yeah, this right here. There we go. Right, so that will be how much memory I actually need for the rope strings. And then when I do the actual initialization, I use that again to space them out. And for the nodes, that will just sort of be do I need a free list of nodes? It seems like I'm going to need a free list of nodes. I think I've already introduced that concept somewhere. Yeah, so I'll just say when something is freed, its parent is the next free thing. And if that parent is 0, again, 0 will be the special node that is always the root of the whole buffer, and so it doesn't ever become free. Okay. That seems reasonable. This returns 1, or a true value, if and only if the buffer was successfully initialized. Um, so where should this start? Guess I'll set the free list up for node strings, and then I'll just start allocating out of that right away, rather than trying to like get the free ones and then set up the free list with the other ones and blah 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 blah. I'll just allocate the free list as if everything is free at first. So to do that, I need to set the string count, and of course I calculated that the wrong way. You know what? Okay, that's a little better. Ah, lost one of my candies. That's sad. Okay, so at this point, the buffer's rope string count, I believe it has that variable too, will be the init's rope string count. And the local count variable will also come into play now. Oops. I'll actually do it this way. And then loop across, and let's see, I'm gonna need an I here for that. For each one of those, well, the next thing I'm gonna need is like a pointer which starts off at the beginning of buffer data, and then each one next free rope string equals this rope string here. Oh, there's a problem. There's always a problem when you have this many pointers. Free rope string equals 0. And the rope string, his next free is an integer. which will always be rope string full size. I have a quick question for myself. Okay, good. Times I plus 1. Right? And then after each one of those, rope string equals hello Carmen Cipher. I'm currently working on a data structure called a rope, which is basically a tree where the leaves store some strings, and when you put all those strings together you get a big text file, and it's part of this project I'm working on right here. I've got some other text buffer types, a gap buffer, a multi-gap buffer, a golden array. The rope is the newest one that I'm just starting today. If you want to take a look at some of this code, I'll send you the link right here in the chat. And this is all for 4coder, which is the text editor / code editor that it's being built for. And right now I'm just getting the rope string or the rope data structure started. Okay. So that's the free list. That's good. And then from there, I have a bunch of nodes. I know that the rope string count is how many ropes I want to, like how many strings I want to store the whole thing in, right? So I can divide this by that and figure out how big each one needs to be. So to kick it off, it's something like okay, I got it. Okay, so what I need to do is I need to start by making all of the base level nodes that I'm going to have. So these 8 nodes here, they each need to have their pointers or whatever to the strings, their references into the strings that they're going to use separately, and I'll keep a stack of all of these guys. And then what I'll do is I'll say, okay, pop 2 off. It's more like a queue. Take 2 off and combine them into one node. So it's like if this is a queue of 8 things that I start with, I'll take 2 at a time off and I put them on at the end here. And then I take the next 2 off, and the trick is these have to be put in order so that I know that they're always like coming through. So I put like I first grow it so that this is the beginning of the file and this is the end of the file. And once that's done, once I'm done growing it like a stack, I start using it like a queue after that. So I start from here, and then I want this one and this one. The queue will move this way. So I read this one and I operate on it. I read this one and this one and operate it, and my pointer is hanging out right here. When I'm done, I put my result here. And I read these two and I put my result here, etc. And so I'll know, okay, alright. So first things first is grow this like a stack, where I start from the beginning of the file and I create a node and I put, okay. That seems reasonable. Count, and I need to know for each one of these, should I set up a free list on the nodes as well? It seems like I should set the nodes up to be a free list right away too. Right, so let's do that first. Okay, so the free node is 0, I have to set the nodes themselves still, and it seems like, oh wait, no, that got set when I was passing in pages of data, right? So the nodes are actually set. I just need to get the first node, which I can get right here, and then this one is a lot easier to advance forward, because they're all just the actual width of the struct there. And that struct is 6 integers, it's not bad. Hello, Picarion, welcome. So what I need to do is say that the node's next, or the node's parent for each one is I plus 1. And this up here, I did skip an important step. That final rope string is valid, and it needs its next free to say 0. kind of interesting what I have to do later. Okay. Next up, I need to say node down here. The node's final parent is 0. And from then on, what I want are functions that sort of will help me out. And init for getting nodes and why not? So let's see, the buffers. I need the ability to allocate rope string. That returns whether it's successful, and then the output would be right here. Okay. So that sort of does an allocation off of the free list. And then to add someone onto the free list is pretty easy. Again, don't know if I'm actually using the right term there. That should just always succeed. Rope string. And the question is, do I want to specify an int or a pointer? It's a bit of a tough call. If I specify a pointer, then it basically turns into which one do I think I'll have more of. And since I store everything as ints everywhere, well, for one thing, this here should just add in the size of the rope string header, because that's actually irrelevant. And then what I'll do is I'll say you always pass in this string start, and the This idea of success is gone. This always succeeds. The result is not a thing. So how does that work? Okay, so first I want to get you. And this could work the same way up here, where I get this thing first by that line of code. Then there's the result. The next free guy. So string start minus the size of loop string. Steps me back to where the actual string header exists, and I'll then say, okay, great. Actually, he's the one I want, so I had this up here correct. This should get from result. And the rope node that I just, free rope node, not sure why it says that. That should be free rope string, right? String. Rope string next free rope string. So then the rope string's next free is equal to the buffer's next free string. Free rope string, and then the free rope string equals string start. Okay. Makes sense. Makes sense. Same pattern again will work for rope node. The difference here will be that we don't care at all about strings, so I'll just call it node. Int result doesn't need to be incremented. Success. Still important. Free rope node. No, that's another one that needs to be a rope string. This one, rope node. Good. Just to check, I have those up here, right? Free rope node, free rope string. Right, okay. Success result equals free rope node. The rope node equals the buffer's nodes plus result. The free rope node equals the next free node. That one is greater than 0. So that's how I allocate a rope node. Here's how I free one. Int index. Don't need any of that. Rope node. Node. Nodes plus node index. The node's next free is the buffer's rope free rope node, and then the free rope node is the node index. And there's no next free member on the node. They have that denoted by their parent field. Okay. Okay. So that sets up all of the free lists inside the memory that we have. And then what we want to do is I need to set up a root node. I'm going to comment this one. Initialize the free list, initialize the root. Now, there's technically two ways I could do this. If I did it depth first tree builder, that might be pretty good. Because I could then walk across the input text of the file to build the actual strings, and I would be able to have a simpler data structure than that one I was looking at earlier, where it builds like a stack but then reads like a queue afterwards. And they would also allocate in order so that they aren't like root first and then a bunch of leaves and then a bunch of in-between things all jumbled up in a weird order. It would just go top of the tree downwards when I first initialize, which is a little bit nicer. Alright, so yeah, I'm going to do that. In order to do it, what I need to do is say that I have a stack that keeps track of what I'm doing at any given stage. So that would have to look something like this. I would say here's my root. It's got a left child. Why doesn't the root have a left child and a right child, I wonder? I mean, sometimes it's nice to be able to say like, oh, everything has a parent. So maybe the idea is anything that has a left and right child, you want it to have a parent. So you have this guy up here who's sort of outside of the actual tree as your root. And then also, since he's going to have the sum of the left-hand side, it's not until this part where you have the sum of all of it, right? Sorry if my hand was blocking the mic there and you couldn't hear me. I wasn't paying any attention. So, I wasn't paying any attention to that anyway. So, I think I'll stick with that, and then the idea is the first thing you do is you say, push on the fact that you want to allocate this, And that thing needs to know a few things. It needs to know that it's the left-hand child of this. So it needs to know who its parent is and whether it's left or right. So it needs P, and it needs either L or R. And it needs to know the size of the string at that point, right? The size of the string that it's going to contain. Which, if this guy knows the whole size, right? This guy knows S, then this right here, his total is S, and his left-hand side is like S divided by 2. So he also needs S over S and his left-hand side. But carry on, I've been streaming. I streamed since it's been about 2.5 or 3 hours almost. My first stream was a couple hours, and I just turned it off and turned it back on so that I could break it up into smaller videos. But I'll probably go for a couple more hours today. I've got plenty of time, and I'm trying to wrap up this buffer experiment this week, or like getting all the buffers set up so that I can wrap it up next week. In other words, I want to finish this rope thing this week. Well, I could just tell it its size, right? I say, here's the size, and it'll figure out its left-hand size by dividing that by 2 and figuring out that stuff for itself. And then I add that to a stack. And then what it does is it pops itself off the stack and adds these 2 to the stack, adding right-hand side first and then left-hand side. That way it'll do left-hand side first and then later get back to the right-hand side. Seems pretty good, right? That seems doable. So everything that I need in one part of the stack is the parent who needs a new child, whether I'm the left child or the right child of that parent, and the size that I want to store there in that node. If I have a parent, if I reference back to the parent and the parent knows inside, I might not even need this because I can get that size from... No, because the parent needs to decide what size it wants to go to each one, so it'll pass the size on. Okay. So with that, rope construct stage. Okay, and then I need, whoops, that should all say int. Just occurred to me that it seemed like I'd been saying I32 at some point, and then I had been. Okay, so I'll call this the initialized tree part. It'll initialize the whole tree, actually. Anyway, parent index is left side weight, right? That information in a stack will be enough. Now the question is, in the past I've never had the end init function take in some scratch buffer memory, but I think that's what it's going to need here. Alright, so that's not terrible news. Let's just go ask for it. Okay, add to the top of the stack. And then I want to make like a quick constructor function. Alright, so the parent is 0 to begin with. Left hand side is true. I'm going to switch that. I want 0 to be left. Is right side. Right. Left. Right. Parent of 0 and a weight of the full size of the entire file, right? And then begins a for loop that will basically go while top is greater than 0. And then what I want is like a stage pointer that goes stack plus top. and I want to go, okay, if that stage has a weight greater than the rope construct rope string width, do this logic, otherwise do this logic. And logic it does in this case is it figures out how much it's going to give on the right hand side and how much it's going to give on the left hand side, and it pushes twice onto the stack. So stack top plus plus equals buffer construct stage once and twice, the right hand side and the left hand side, each time saying with this as your parent, so node index as parent, and left hand side here, right hand side here. Right hand side is this divided by 2. Is this minus this divided by 2. And the reason I don't just divide by 2 twice is I might have a round down going on. So that makes sure that the left hand side gets the bigger part. If I need an odd number, right? Now, I know what you're asking, where's that node index going to come from? And that's okay. We'll find it somewhere. So, to get that node index, I probably want to do buffer allocate rope node. It knows what I want. From the buffer, get me a node index. If you succeed, go ahead and do this stuff. First thing you should actually do is look at your nodes and give me that node, because I would like to tell that node that it has let me pull up the rope buffer. I need to tell that node that it has some information. A total of init size, a left total of this math here, could just do it this way, which simplifies it quite a bit. Minus the left total. Right? So it gives me a right hand side and a left hand side. String start is not a thing here, but left, right, and parent all will be. And I don't need to set left and right because they'll get set down here later. But I do need to set the parent to stage parent, right? And I need to go get my parent node later and deal with it. And it makes me think that what I actually should be doing is saying that all of this happens here, and it's just inside this if. Oh, this else wants to go in here. Right, okay. And then I find node, I find parent, I set parent, I set the total. If I need to split it, I set the left total like so. Down here I'll set the left total exactly the same as the full total. Stack top. Wait, why would I do that? Seems like it'd be better to set the left total to 0 here. And then stack top plus plus, construct the stage, the node index 1, the node index 0, which gives me my two children. Down here, I can set result to 0 and break out of the loop. So I know I can set result 1 up here before all this starts at least. Right, so that's cool. And we need to be asserting all along the way that top is strictly less than max top. Oh, stack max. There we go. And the only thing left to do is, after that has happened, set the node to the parent and ask that it's, well, if stage right or is right side else, and then it's node right equals node index, else node left equals node index. Okay, so now the only thing I haven't done is this section right here, which needs to do the rest of the work to allocate a node string, a rope string, and associate it to the node. And to do that, interesting. Anyway, to do this, I'll be setting string start. Left and right need to go to 0. Total has already been set, parent has already been set, and my parent's going to find out about me below. Can actually shorten this, which is nice. And the only thing left to do is set the string start, which is buffer alloc rope string. From this buffer, I need the nodes string start. Then I'll do some work with that. If I don't get what I want, result equals 0, break. Okay. Almost done initializing this, so now what's going on is we've gotten down to the leaf node, we've allocated a rope string, and we've got the start of that string. We just need to copy a part of the main string out. This is the part that is pretty cool. We throw these in here. Sir dest, and I'll put in like read position, read end, and just to initialize some stuff. Right, and then with each of these, what should happen is I should go, I have dest, right? Yep. Dest equals the buffer's data plus the node's string start. And then I want to copy into the dest from the source plus the read position with the amount of the node's total size, and then I want to take the read position and I want to add in that total size one more time. That gets me reading along, and since I'm making sure I'm doing depth first, left to right, I should come out correct. Alright, so that's a pretty good start. I'm going to see if it builds. Not too far off. Parent index. Okay, so it's building. If this runs without crashing, then I'll say that it's officially sort of, not necessarily working buglessly, but it's at a good stage for today. It's at least able to pass a basic requirement of successfully trying to initialize, and in the future I'll work on getting the stringify working so that I can render the file and see that it works when I'm streaming it out too. Let's see. Haha, no asserts. So, one last thing I could do just to see that it's kind of sort of working is draw file view. It's not going very far into this function, but it is going into this function, so I can stop here and look at the files buffer, and inside there just make sure that what we're seeing is kind of like a good looking buffer. It's not really though, is it? It's all null. Nodes is null, data is null. Yeah, why are you all so null? That's not good. Okay, so something went wrong. Let me pull up, let's see, I don't need you open anymore. Let me pull open this code and take a look and see if there's any good reason why that should be happening. Uh-huh. Buffer end init. Oh, I have to go and lift the scalpel off of something. Buffer end init. Yep, this right here isn't even running. Right, I changed the interface. I should have thought of that. Okay. So, in order order to get that temporary scratch buffer, it's not too hard. I just need to go ahead and look at partition part equals, oh, I've only got general memory. Why did that happen? Okay. Well, this is going to change a little bit of stuff here. So, we got some cool stuff to do. I need all of my memory, which means wherever I was saying general down here, it's now the general portion of the memory. That's fine. Yeah, so for all of these people who want general memory, I'll just create that pointer. Okay. And then what I want to do is all of the buffers need to keep having the same interface. So these all take a scratch and scratch size that they don't use. Golden array, gap buffer, and init, multi-gap buffer, and init. And then it's just this error here we have to deal with. And to deal with that, I'll just take okay. Oh, we did break eventually. And its success came back as a 0. Okay. That's good. That means that we can catch some bugs now. result is 0. We begin initting. What is the max, stack max here? Stack max is not even set yet, so don't worry about it. This here should go fine, and for a long time, so should this. So that's great. Rope string count, node count. Very good. Rope string count is pretty big. Not totally sure that that makes any sense, but maybe it does. Buffer construct stage. Cool. So what I should do is take a look at the stack and just keep the first like 20 entries in view. So that one is in. My top goes down, and I've now pulled this one off the stack, and the stack is empty. But then it goes, okay, can I allocate a node? It can, it gets 1. Sets the parent. Sets the total. Is that weight too big? It is. So it says the left total. And then stack max. Put some stuff on the right hand side. That goes there. Put some stuff on the left hand side. It goes here. Cool. Then it goes to the parent. Right? Oh shoot. Our pointer to stage can be updated right there and lead to a bug. Okay, so 255. We need to store the parent index. How is I not finding the one I want? Wait, I don't need to do that. I'm storing it in the node. The node should be safe. So I'll just grab the node's parent. Go to your parent, take this node, go to its parent, and then there you go. Okay, see if that's better. You do a bunch of work, you get to here, it's all good, you're ready to initialize, and you come in here. That parent was 0, so now you're looking at this guy, who's all zeros still. You set his right side is 1, so you set his right to 1, that should be his left. Buffer construct stage. Well, I can either do this up here and then I have to move the node extra times, or I can stash this around for later. stash it. Okay, we come in. His right side is 0, so the left hand one becomes a 1. Right? His total is wrong, so I should fix that, but let me keep going, because that shouldn't affect anything else. Comes up here, allocates a node. It's not working on this one. Okay. His parent is 1, his total is still that big, huh? 102,992, is that real? That's a bug. That should be stage size 256. And then the other thing I need was up here. The parent doesn't know everything it needs to know. It needs to know that its total size is the init size. It needs to know that its left total is the init size. That's weight. Okay. Put some new guys on the stack there. And then round we come. Get the next thing. It's a 2. Here's the parent. Here's the total is better now. Right side should still be 0. Weight is still too big. So it comes in here again. The total. Oh, that shouldn't be init size either. That should be stage weight, right? 261. Comes around once and that's fine. Puts that into there. Looks good. And it's still gonna fit, so it goes ahead and puts in new stuff. Puts in another new thing. So these are both the children of 2 that need to be constructed. You can still building up the things that it needs to do on the right hand side for later. And then it comes through again. The weight is still too big, but it gets halved again. And we put in you, and we put in you. Alright. And we come around, we do the left hand side again. We're still on our left hand side. Total. Here's the stage's weight. It's too big, but we half it again. And we put in 2 new nodes. Came out odd this time, which means we have a good chance of seeing it not be equal on the next round through, which is going to be cool to see. Alright, so his parent is 4. Eight, 3219, 3218, cool. Those are still too big. 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 That's not too big, so it should work this time. It comes in and goes, aha! I can fit this into a rope string. So my totals are all 0. I don't have any children to have a total beneath me. And I have no children. I figure out the string start, which is comes out as a 4. And let's see. That makes that the destination. I do a memcopy into that position, which puts in a bunch of the text from the file, and I increment the read position. So what I should add is an assert that when this is all done, the read position is exactly equal to the size of the whole file. But it looks like it's working now, so I'll let it run through. Hey, no fatal death that time. Let me see if I go to File, Draw File, View. Put in a breakpoint there and trigger it. Do I get a good-looking buffer this time? And by good-looking buffer, I understand that there's a limit to what a good-looking rope buffer will look like. So the free rope string is -1, which suggests that it's exactly out of rope strings. Which might mean I need to indicate whether or not I need extras directly. I can't just say, hey, figure it out for yourself if I need extras. Also, this seems to think that the free rope node is 1024, which is impossible because that's like beyond the list of nodes. But what I can do right now is take a quick look through all 1024 of these nodes. Has a left-hand child of 1, and that's it. 1 has a left of 2 and a right of 513. Left, 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 left. These right here are child nodes. They both contain strings. String start of 4. String start of 260. Pretty cool. Verifying the correctness on that, we'll have to wait for another time, because I think that is enough for this particular stream. Thank you, everybody who came out and watched some stream and who came to support 4coder. I'll see you guys.